Hello, pre-calc students. Doing a walkthrough of the exponential function. So we need to solve for b. We have b to the 5 is equal to negative 1024. In order to isolate b, you could raise b to the 1/5 power. After you raise b to the 1/5 power, that will cancel out your b. Yeah. Watch. Yeah. Focus on what you're doing. I'm trying to kill two birds with one stone here. So you spend 20 minutes focusing on your issues with polynomial and rationals, and I'm going to focus on making a video for exponentials. And so, you know, some more resources too. So, anyways, b to the 5 raised to the 1/5 power. By the way, it's the same thing as having b to the 5 equals negative 1024, and taking the 5th root of each side. So, anyways, this is where I'll prove it to you with the calculator, but negative, I'll put this all in parentheses, negative 1024 raised to the 1/5 power, that's equal to negative 4. So b is equal to negative 4. Let's hit submit. Oh, and it appears that we have locked out of the course page. Alright, I'll go back to the test directly. Alright, same logic here. In clear annotations, I take 1296 raised to the 1/4 power, and that's equal to 6. b is equal to 6. Wait. We attempt, there's multiple, I guess it would be equal to 6 or negative 6. So b cubed is equal to negative 8. Find the cube root of each side. The cube root of b cubed is equal to the cube root of negative 8. So that's going to be equal to negative 2 times negative 2 times negative 2 is negative 8. And there's only one solution here, not 2. So the answer is just negative 2. Alright, and that's our solution to question 1. For question 2, we're using the like basis properties of and exponents to solve the equation. So you have 4 times 3 to the x minus 20 is equal to 88. What I'm going to do next is add 20 to each side. So 4 times 3 to the x is equal to 88 plus 20. That's going to be 98 108. I divide each side by 4. 108 divided by 4, that's going to be, let's see, that's 5427. So 3 to the x is equal to 27. Alright. And I'm going to rewrite 27 as not 3 times 3, but 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. So 3 to the x is equal to 3 to the 3rd. And when I have my common base, I can eliminate my common base and just have my exponents equal to each other. So x is equal to 3. Question 3. Use the like basis property to solve the equation. First, I need to add 9 to each side. negative 36 plus 9 is negative 27. So I have negative 1 times 81 to the x, add 9 to each side, is equal to negative 27. Divide each side by negative 1. Cancels out. Turns as negative 27 to positive 27. 81 raised to the x power is equal to positive 27. And now I'm going to rewrite 81 to the x as 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's 3 to the 4th. 81 is 3 to the 4th to the x. And 27 is equal to 3 cubed. So simplifying, 3 to the 4 to the x is the same thing as 3 to the 4 times x, law of exponents. So 3 to the 4x is equal to 3 cubed. Cancel out 3's. 4x is equal to 3. X is equal to 3/4. 3/4. Question 3 is correct. Moving on. Use the like-base property to solve the equation. 3125 to the x is equal to 625. So I know 3125 must be 5 raised to something. So let's see, 5 raised to the 5th power is 3125, and I know 5 raised to the 4th power is 625. So after verifying that with my calculator, I have 5 to the 5th power to the x is equal to 5 to the 4th power. Yep. Yes. So that's 5 to the 5x power is equal to 5 to the 4th power. I have a common base of 5. Eliminate that common base. 5x is equal to 4. Divide each side by 5. X is equal to 4/5. Question 5. Oh. 2 to the x equals 116. Alright. Use table and graph to find the solution accurate to one decimal place. So here we're just going to do logarithmic conversion. If 2 to the x equals 116, log base 2, swoosh, there it is, of 116 is equal to x. So I now take my calculator and evaluate math, up, log base 2 of 116. And that is equal to 6 point, accurate to one decimal place. So 6.9. 6.85 is going to simplify to 6.9. That's going to be 6.9. Alright, that is considered correct. Let's move to question 6. Alright, we have a logistic function. Alright. Which one of the functions below is represented by the graph above? Where I see that our carrying capacity is at 70, right? So our carrying capacity is at 70. So you have your horizontal asymptote at y equals 70. So we can eliminate any numerator that's not equal to 70. So we can eliminate the first and the third problem. And what we can also do is know that this is flipped 70 and flipped across the x-axis. So the best way to do this really is to with the function with the carrying capacity of 70, we can use Desmos to model the problem. So pull up Desmos, and let's pick rules. Yep. Okay. Cool. All right. Sorry about that. So let's pick the first problem with a value of 70. 70 over 1 plus 0.75 times 1.5 to the x. So let's do y is equal to, let's see, what's the issue? 70 over 1 plus 0.75 times 1.5 to the x. times 1.5. That might work better, to the x. Okay, there we go. So this does give us a logistic function. The question is, does it match up with the graph? And one way to do this is to see where does it intersect the y-axis? What's the y-intercept here? Has the y-intercept at 40, and so it looks like this is a great candidate because the y-intercept is 40. If you were to have 1.5 to the negative x, which is where it would have a more traditional shape, 1.5 to the negative x, it's going to have the function is going to have the wrong shape. It's going to have a traditional logistics function, as opposed to without that negative x, the logistic function is shifted across the y-axis. And then you have 2.75 to the 1.5x. And if you had a 2.75 to the 1.5x, you wouldn't have that y-intercept of 40. See, now your y-intercept is less than 20, so that's not correct. The correct answer is 70 over 1 plus 1.75 to 1.5x. And so you can get that question right really just with Desmos and under looking at exploring function transformations. All right, so let's submit. Got it right. Question 7. I use the like basis properties to solve the equation. We have a common base, so we can cancel out. N plus 3 is equal to 3n plus 5. Subtract n from each side. 3 is equal to 2n plus 5. Subtract 5. Negative 2 is equal to 2n. Divide each side by 2. Negative 1 is equal to n. And so we just solve for n right there. Question 8. Solve the equation. I guess they don't want us to use our calculator, so let's do 80 divided by 5. Well, 5 times 8 is 40, so 5 times 16 is 80. So divide each side by 5, and I'll have 2 to the x is equal to 16. Knowing, I just got to know that 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 is 2 to the 4th. So I have 2 to the x is equal to 2 to the 4th. Cancel out my bases. Set my exponents equal to each other. X is equal to 4. Question 9. Use the like basis property to solve the equation. So divide each side by 3. So 48 divided by 3. 16, 32, 48. 2 to the n is equal to 16, because 16 times 3 is 48. Then this becomes the exact same problem we had last problem. 2 to the n is equal to 2 to the 4, n is equal to 4. Alright, that's right. Let's go to question 10. Like basis property. So this one's a little bit more tricky. I'm going to rewrite 9 to the x. I see a common base of 3 as 3 squared to the x. And then I'm going to rewrite 1 over 81. That's going to be 3 to the negative 4, because 3 to the 4th is equal to 81. That's 3 times 3 is 9, times 3 is 27, times 3 is 81. But 3 to the negative 4th is 1 over 3 to the positive 4th. 3 to the positive 4th is 81, so that's equal to 1 over 81. So that being said, 3 squared to the x power is equal to, keep on going for a little bit, one over 3 raised to the negative 4th power. So 3 squared to the x power, that's 3 to the 2 times x. So 3 to the 2x is equal to 3 to the negative 4. 2x is equal to negative 4. Divide each side by 2. X is equal to negative 4 divided by 2 is equal to negative 2. So x is equal to negative 2. Alright, that's right. Move along. Clear annotations. Solve the equation. So my first step is always to subtract. So I'm going to subtract 90 and negative 774 minus 90 is negative 864. Divide each side by negative 27. And you have 32. So now you have b to the 5th is equal to 32. I can rewrite 32 as 2 to the 5th. That's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So b to the 5th is equal to 2 to the 5th. And if b to the 5th is equal to 2 to the 5th, then b is equal to 2. Hopefully you can kind of see that logic. You take the 5th root of each side, and b is equal to 2. Alright, clear annotations, move on. Question 12. So, almost done. A certain community consists of 2,600 people. One individual has a particular contagious strain of influenza. Assuming the community has not had vaccination, all are susceptible. infectious disease is modeled by this logistic function, where A is the number of people who have contained the flu after T days, okay? How many people have contracted the flu after 6 days? So all I have to do is plug in 6 for T. So we take out our calculator and we evaluate alpha y equals 2,600 in the numerator, and then 1 plus 2,599, this is more of a calculator question actually, times e raised to the negative 0.65 times t, but this is when t is equal to 6, so times 6. Just plug that all into the calculator. And that's 48.499, so that will round up to 48.5, so that should round up to 49. But I don't know what exactly their rounding issue is, so round to the nearest whole number. So that's one of the carrying capacity, that's just the numerator of the logistic function, so that's going to be 2,600. And how many days will it take for 575 people to contract the flu? That's going to just require us to set A equal to 575. The fastest way to do that is to actually plug this function into Desmos, find the intersection with 575, and find that intersection. So, in Desmos, the carrying capacity is 2,600 times 1 plus 2,599 times e to the, and I'll show you to find e. I just found e in this section of Desmos, raised to the negative 0.65t. E to the negative 0.65 x. So that's my logistic function. This is the logistic function right here. Let's take a look. And we are going to look at the intersection between this and when y is equal to 575. So we have y equals 575. And we look for this intersection. And this intersection is at 10.16, 575. This should take approximately 10 days. Hit submit. Alright, I bet they wanted the answer to be 50 people here. Or no, so sorry, 48. Because I rounded up instead of rounding down. So, attempt. Carrying capacity is 1,900. In Desmos, alter our graph so that the carrying capacity is 1,900. Our coefficient is 1,899 times e to the negative, now it's negative 0.45x. Okay, and now I'm going to look at the value when x is equal to so after 8 days, I'm going to look at the line x equals 8. So that's an aspect to x equals 8. And you have 8 35.925, so that's going to be 35.925, so it's going to round to 40. And how many days will it take for 200 people to contract the flu? Now I have y is equal to 250. So that's going to be 12.582, 250. So 12.582, that's going to round up to 13. Now I should be able to hit submit and get after 40 to 1 plus 18999. X equals 8. Oh, when this intersects with the that's 35.925. Oh, 35.925, that rounds to 36. So that's my fault for, yes, 35.9 rounds to 36. Let's look at our attempt, but perhaps I'm plugging it in to get Desmos wrong. 3,600 times 1 plus 3,599 times e to the negative 0.7x after 13 days, 2567.9, so that should be 2568. Maybe they want us to round down. Let's just try 2567. Carrying capacity is 3,600. How many days will it take for 475 people to contract the flu? That's when y is equal to 475. That says 9 days, approximately. So I tried rounding down instead of rounding up. And the attempt. 2,600. 2599 e to negative 0.65x. After 12 days, the output is 1259.14. So that should be unambiguously 1259. Carrying capacity is 2,600. 575.
Pardon this interruption. Ryson Jr.'s last name starting with I, J, and K. Please report to the media center.
Alright, so that's 10.16. That should just be 10 days. So, okay. This has been picky, but you just need to make, if you try it again, hopefully Desmos intersection will work out. Question 13. Find the solution to the exponential equation. Take the natural log of both sides. So log base e of 39 is equal to 2x plus 1. The ln of 39 equals 2x plus 1. The ln of 39 minus 1 over 2 is equal to x. So what I do is I evaluate the natural log of 39 minus 1 divided by 2. That should be equal to x. The 4 decimal places, that's 1.3318. 1.3318. 1.3318. Alright, 3 more questions. E to the 1/4 x equals 16. So the log base e of 16 is equal to 1 minus 4x. Means that ln of 16 minus 1 is equal to negative 4x, which means that ln of 16 minus 1 over negative 4 is equal to x. So take my calculator, evaluate the ln of 16 minus 1, divide this by negative 4, and the answer is going to be negative 0.4431. Negative 0.4431. That is correct. Moving on. Find the solution of the exponential equation 100 times 1.03 to the 2t is equal to 500,000. Divide each side by 100. 1.03 to the 2t is equal to 500,000 divided by 100. So 500,000 divided by 100, that's going to be 5,000. So 1.03 to the 2t is equal to 5,000. Alright, and now I do a log base. Log base 1.03 of 5,000 is equal to 2t. So that means that t is equal to the log base 1.03 of 5,000 divided by 2. So I take out my calculator. And I find the log base 1.03 of 5,000 divide this number by 2. That's equal to 144.0720. 144.0720. That is correct. Question 16 is the last question. Use the like basis property to solve. Subtract 38. 5 times 10 to the n is equal to 5,000. Divide each side by 5. 10 to the n is equal to 1,000. Alright, and 10 to the n is equal to 1,000 is 10 to the 3. So cancel out the bases. N is equal to 3. Alright, that's the entire video. Have a great time.